dividing complex numbers. So for example, say that I'm given 4 plus 2i over 1 plus 3i. So just like with rationalizing binomials with radicals, in the denominators, we times by what's called the conjugate. We do that same step here when we have things with i's in it. So we're going to times by 1 minus 3i because that's the conjugate to 1 plus 3i. And we're going to have to FOIL. So here comes our multiplying complex numbers right into play. So on top, I get 4 minus 12i plus 2i minus 6i squared all over. Remember, with conjugate pairs, you actually have to times the first two and the last two together because those inner terms will always cancel out. Combining like terms, 4, this is negative 1, so it's 4 plus 6, or 10. Negative 12i plus 2i is minus 10i. Remember, this right here is minus 1. So in other words, I have 1 plus 9 here. So I have 10. Reducing everything, I get 1 minus I. Five minus 4i all over I. So the conjugate to I is timesing the top and the bottom by negative I. So I have negative 5i plus 4i squared all over negative I squared. Remember, I squared is negative 1. So I have negative 5i. Instead of I squared here, I have negative 1 or negative 4. Negative times negative 1 makes positive 1. Rearranging the top, just flipping them so the number without the I comes first, I would get a final answer that looked like negative 4 minus 5i. Because it doesn't reduce or combine any further. So remember, I squared is negative 1. If we want to get rid of an I in a denominator, similar to rationalizing, if it's a binomial, we times by the conjugate. So the conjugate to 1 plus 3i is 1 minus 3i. The conjugate to 5 minus 2i would be to times it by 5 plus 2i.